Okay? So that's a little law. It's a little rule we're going to have down here in a sec. But I just wanted to tell you that so far you haven't seen a negative exponent. This, we already kind of saw a pattern thing. Let's look at it again. 10 cubed, that's 10 times 10 times 10. That's 1,000. 10 squared is 10 times 10. That's 100. This is 1 less 10, right? If I divide this by 10, I get this. This is only 1 10, not 2 10s. If I take 100, divide it by 10, I get 10, right? 10 to the 1 power, that's 110. It's 10. 10 to the 0, well, you can think anything to the 0 power is 1. But look at the pattern. What's 10 divided by 10? 1. Either way, it works. Let's keep going. Because this is where it stopped last day. Now we have negatives. 10 to the minus 1. See how it goes 3, 2, 1, 0, minus 1? Well, what's the pattern? Divide by 10. That's 1/10. Okay? And 10 I can write as, remember, 10 to the 1. So that's 1 over 10 to the 1. That's the same as this. If I have a negative exponent, to make it positive, all I do, if it's on the numerator, flip it to the denominator, put a 1 over it, and now it's positive. Okay, look at this one. Negative 1 exponent, how do I make it positive? Flip it down to the denominator, put a 1 over it, and now it's positive. How would I make this thing positive? 1 over, and now it's positive. Is that 1/10 divided by 10? Yes, it is. Otherwise known as 1/100th. Okay? Let's look at the pattern. What's 1/100th divided by 10? 1/1000th. But if I want to make that thing positive, I just put a 1 over it. And is that the same thing as 1/1000? Yes, it is. Right? Okay? It doesn't matter what I have for my base, what I have for my exponent. Okay? That's 1. Divide by a. Right? Divide by another a. Okay, you can think of it in terms of pattern, or what we're telling you, if you have a negative exponent, you want to make it positive, 1 over it, and it becomes positive. Okay? That's what we kind of proved up here, but we're going to prove it again. First of all, who's got this? Who's really quick? 10 to the minus 7. I want to write that with a positive exponent. You don't want negative exponents, okay? Because, I mean, who knows what that is? We don't know, okay? But I do know 3 to the positive 3 is 27, so that's 1/27, okay? How do I write that positive? What do? Put 1 over it. Now it's positive. How do I write this positive? 1 over it, and it's positive. That's called reciprocal, by the way, but we don't need to know that, okay? All the terminology, that was on our last test, okay? You just need to know, to get the mark, that's all you do, okay? Is it positive? Yeah. Doesn't even say evaluate. I should be able to know what 3 times 3 times 3 times 3 times 3 is, but it doesn't say it, so that's good. How do I make this thing positive? 1 over it, and it's positive. So far, so good? Not too bad? All right, just wait. Just wait. Okay, consider, if you will, this expression. First of all, you don't want to write it like that. Okay? You probably want to write it like that. Can I expand this out? Yeah, 5 to the 4. Let's write it over here. is 5 times 5 times 5 times 5. That says 4 5s, right? 5 to the 7 on the bottom, how many is that? 7. 5, 6, 7. What's 5 divided by 5? 1, 1, 1, 1. I have a 1 left on the top. How many 5s do I have in the bottom? Okay, so this is 1 over 5 to the 3. Use the quotient law. I'm dividing. I have the same base. I subtract my exponents. What's 4 take away 7? Negative 3. Therefore, this is the same as that. Okay? To make this thing positive, 1 over it, and it becomes positive. Okay? So again, we proved it. It must work because I just did it 2 different ways and I got the same thing. So this same thing must be the same, right? Kind of like a transitive quality, but maybe that's a big T word. Okay. Blah, 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 blah. Complete. What can I do to make that exponent positive? For the 7th time, 1 over it. Everything stays the same. The base is the same. The exponent p is the same. The only thing that changed was it was negative. Now it's positive. Okay? I don't care what a is. I don't care what p is. If I just want to make that positive, that's what we do. And usually that's the first thing you want to do to solve these, is get rid of the negative exponent. Okay? Because you don't know what that is. But this, we can find out. Okay? Write the following positive exponents. We just did this. Let's do it again. How do I make this thing positive? 1 over it. What's 2 to the 1 power? 2, right? 1 2s. 1/2 is also known as, what is a decimal? 0.5. You know what? Let's check this one. Do you guys know how to put a negative exponent in your calculator? And you might have a different exponent button. Texas Instruments, we don't have a y to the x button. That's my exponent button. 2 to the power of negative 1. Oh, what do you know? It's the same thing. Okay? 0.5, 1/2. So I just proved that one too with my calculator. All right? You probably have, if you got a Sharp or a Casio, that's your exponent button. Right? You probably have a square button too, but remember, these aren't squares. You need a button to use all the exponents. Well, they're not going to give you 97 different buttons. This you use for any exponent. Squared, cubed, minus fourth, 8th root, whatever, right? Okay? So it was evaluated, 1/2, 0.5, same thing. Does anyone know 3 to the minus 2 power? You don't. But you do know 1 over 3 squared is 1/9. Okay? So first thing you want to do, get rid of the negative exponent. Anyone know 4 to the minus 3 power? But I bet you lots of you know 4 to the 3rd power. This is 1/64. Okay? Okay? Negative exponents. Use the rule for division of fractions to show that is that. Is this different than what I've been showing you the last 20 examples or so? It is. Because everything here was a numerator, wasn't it? Right? Numerator, numerator, numerator. Now, where's the negative exponent? It's the denominator, yeah. So it's the same principle, but a little bit different. So before we see the actual law, let's prove this, okay? So what does this say? 1 divided by 4 cubed. You remember back in grade 8 when we divided fractions? And I said, you don't want to divide a fraction, right? You don't want to do that. Here's a little trick. I want to multiply it instead. I want to multiply. I don't want to divide a fraction. You never want to divide. I want to multiply. What do I do to this so I can multiply it? You flip it. Yeah. You remember that? Okay. This is 2. Let's think baking. Let's think foods. How many half cups are in 1 cup? 2. Okay? That's what you want to do. Same thing here. I don't want to divide. Okay? This is 1 divided by 4 to the minus 3. Okay? But what is 4 to the minus 3 again? Can I write that as a positive? That's 1 over 4 to the positive 3, right? So I have 1 divided by 1 over 4 to the positive 3. I don't want to divide these. How do I multiply them? I flip it. Okay? Flip the fraction. Now you can multiply. It works. It's a little trick. Okay? What's 1 times 4 cubed? 4 cubed. Divided by 1, it's still 4 cubed. Check. I just proved it. Okay? Using rule for division of fractions, which hopefully most of you got in grade 8. I know my kids did. All right? So, a little bit different. Here's what was on the first page. If you have a negative exponent, to make it positive, you put it on the bottom. You flip it. You put 1 over it. If it's already on the bottom, where do you have to flip it? Onto the top. Okay? So it's very similar. It's just a little bit different. Think of this. If this helps, I can say that's a to the minus 1 over 1, right? All I'm doing is flipping these. 1 goes on the top. This goes on the bottom. Okay? This goes on the top. The 1 goes on the bottom. If that's helpful, think of it that way. I use the word flip because, you know, it makes sense to grade 10s. It is, like I said, it's called reciprocal. Don't worry about that. All right? Get rid of that. Looks kind of messy. Okay? If it's a numerator, make it a denominator. Now it's positive. If it is a denominator, make it a numerator, and it's positive. Okay? All right, a couple of examples. Simplify, express with positive exponents. If the question just says simplify, that means we don't want any negative exponents. They all need to be positive. Here it specifically says it. And then evaluate, and guys, do yourself a favor, don't cheat, because you're not allowed to cheat on the government exam. It says don't use a calculator, then don't use one, okay? Okay, now, we got choices. I'm going to do this 2 ways. First, I'm just going to make that positive, okay? So I have 4 to the 5. He's already positive. He's happy. Leave him alone, okay? This guy's not happy. He's really negative. How do I make him positive? By flipping him to the denominator. Okay, now he's positive. So I have 4 to the 5th power divided by 4 to the 3rd power. Do I have the same base? When I'm dividing, what do I do with my exponents? 4 to the 5 take away 3 is, yeah, and that is, of course, 4 times 4 is 16. Okay? So that's one way, and then everybody hates this. Otherwise, can't you just show me one way? It's so confusing. Well, no, because some people want to do it like that. Other people want to say, aren't I multiplying with the same base? Yes. What do I do with my exponents if I'm multiplying with the same base? What is 5 plus negative 3? Or what is 5 minus 3? Yeah, does that look a little easier for that one? Yeah, it does. Okay? There's more than one ways to skin a cat. And if you're a cat lover, I apologize. But it's just a saying. Okay? So how would you want to do that one? Method 2, I think most of us would like to. That looks a little easier than this. And because this negative thing's kind of new to us, we know multiplication rule. Is that the same base? Okay, what do I do with my exponents? 2 plus negative 5 is 2 minus 5. That's 3 to the minus 3. Oh, but now we have to do something else, because I can't have a negative exponent. They all have to be positive. So how do I make this positive? 1 over 3 cubed. What is 3 cubed? 1/27. Okay? Let's skip C because it's getting kind of cluttered. D. Let's do it the easy way. Are those dividing with the same base? Yes. What do you do with your exponents if you divide with the same base? But you're going to want to write this out because there's a lot of minuses here. Minus 7 minus that one. Minus 7 minus minus 5. What's our little trick when we got a minus minus? Make them plus. Remember our integers from grade 8? Hopefully grade 9? I know some of you do. Okay? So that's negative 7 plus 5 is minus 2. Can I leave it like that? No. It's a negative exponent. How do I make it positive? Flip it. 1 over 6 squared, or, I'm skipping a step here, that's 1/36. Can I try to confuse you and do the other way? No. Oh, please. All right, what is this? Is that multiplying with the same base? No, only one base. That's a power raised to another power. Our rules say, what do I do with the 3 and the minus 1? I multiply them. So that's 2 to the minus 3. 1 over 2 cubed. Make it positive, and that's 1/8. Okay? Well, this is different. They're solving it, and they're saying, is this right or is this wrong? Is this true or false? Dividing with the same base, what do you do with your exponents? Subtract them. What's 3 take away negative 1? You add them, that's 8 to the 4th power. That is true. Okay? Guys, don't worry about that. That's just too killer for us at this point in time. Is this true? C? Don't yell it out. Do we like this, Adam? Yeah, that's our rule, guys. That's our definition of negative exponent. That's right. Where is it? Past it. Right there. Okay? That's it. That's good. We like it. Whoop. Okay, how about this one? Do we like this one? Don't yell it out. Emily? You do? Well, you got a 50-50 chance. Does this negative 3 apply to the 9? Let me rewrite this. That's 9 times a to the minus 3. 9 is positive. He's happy. Let him be. That's 9. This I want to make positive. Is this the same as this? This isn't 1/9. This is 9. Okay? Careful, careful. There's no brackets around the 9a. If there was, this would be fine. But there isn't. Okay? this negative 3 isn't attached to that 9. That's like 9 to the 1 power. Okay? I knew I would trick somebody with that. Today it was Emily's turn. Okay. Simplify and write with positive exponents. This kind of is implied when they say simplify. That's what they mean. Because we're new with this, we're going to say all this. But on the government exam, if they say simplify, and two of the answers are, for the final answers, well, x to the minus 3 is a, and b is something else, and c is 1 over x cubed, which one are you going to pick?
1 over.
You're going to pick the positive one, okay? All right. I don't want to confuse you. Which way would you rather do this right here? Does it look like you're multiplying with the same base?
Yeah, sure are.
What's negative 4 minus 3? You owe $4. You owe $3. Now you owe $7. Yeah, careful. I know integers are tricky. I have to write that positive. That's what it is. Okay? I hate seeing it like that. I hope you agree that this looks a little better. Just for fun, let's write that as repeated multiplication. Because like I said, you can always do this. Okay? 2. How many do I have? 7. 4, 5, 6, 7. 2 goes into 6 3 times. X over x. X over x. So what does this become? 3. How many x's do you have in the bottom? And you're done. Because if you use division rule, you would have x to the minus 5, wouldn't you? 2 minus 7. And then you would have to make it positive. This actually didn't lose us any time at all. Okay? Just a couple more, guys. Does this apply to the x? The minus 3? Sorry, minus 2? Anything else? Let's say it for the 14th time. Does that apply to everything in the brackets? What is negative 2? Well, actually, we want to... Let's make that positive first. Okay? How do I make this positive? By flipping it. That's probably the best thing we can do. Okay? Everything stays the same. I didn't change anything. The only thing I did was make negative 3 positive 3. Okay? Didn't change this minus sign, didn't change the 2, didn't change the x. Okay? But like I said, this applies to everything in the brackets. Negative 2 times negative 2 times negative 2 is minus 8. X times x times x, x cubed. All right? How many more do we need? How many more do we need? Does that look like fun? That would, guys, I could give that to you, but I might call it a bonus question, like now, but on the test. Okay, sure, you could get one. I'm not going to do it because there's 12 different ways to do it. All I'm going to do is confuse you. Because some people will say, why is he doing multiplication rule? I want to do division. That's fine. Why is he doing multiplication rule? I want to do all my negative exponents, make them positive first. That's fine too. Someone else wants to do division first. Okay? That's fine too. There's lots of ways you can do this. But the first thing you'd probably want to do you ever want to divide a fraction? The first step I would do, I'm not going to do it. Not going to do it. Okay, is multiply by flipping this. That's probably your first step. Everything stays the same. All I'm doing is flipping that fraction. Okay, that's the first thing I would do. Now that times in there looks kind of confusing, doesn't it? It looks like an x. Do we need it? No. Okay, that should be your first step. Like I said, there's 10 ways, 12 ways, I don't know, to do that question. Explain why this isn't true. We already did this. It's right here. That's the same as this. Okay? Why? Because this negative 3 isn't attached to that 2. Okay? Negative 3, not exponent of 2. It's the exact same question we already kind of explained. Okay, one more thing. A little trick. If you remember this, it will make your life much easier on the test. You will get a question like this. Look at this guy. Because we got a fraction to a negative exponent. Okay? So if you say to yourself, okay, I remember Mr. Watson saying the first thing I should do is make this thing positive. Okay? So that's 1 over 2/3 to the 4th power. Does this 4 apply to everything in the brackets? Yep, that's 2 to the 4 over 3 to the 4. Brackets are gone. Okay? Do you want to divide fractions? No, you want to flip this and multiply them. And this times 1 is just that. And let me go a little backwards. Is that the same as this? Yeah, that 4 applies to everything in the brackets. This is the same as this. Does anyone see the little trick to make this exponent here positive? What did I do? This, that's not a highlighter. This 2/3, yeah. I flipped it, and that made my exponent positive. Nice little trick to remember, okay? Here it is. I don't care what A and B are. If it's some fraction, oh, let's get a big nasty one. Nasty, nasty. How about, I don't know, 23 over 14 to the negative 7 power. Write that with a positive exponent. Should this be an easy mark? What is it, Tyrell? Done. Easy mark. Hopefully it doesn't say then evaluate, because that's going to be a big nasty number. Okay? But that's what this says. I don't care what A, B, and N are. This is anything as long as you can't divide by 0. Okay? That's to make a professor happy somewhere. Okay? Negative exponents. You have to do this if you want to have any sort of chance to pass this test, which is probably, I don't know, next Friday, probably. Okay? Don't quote me. Our quiz, of course, we'll put off till Monday. All right? Oh, yeah, right. Oh, and it's probably going to be Thursday. Even sooner. Even better. Thanks, Tyrell. You made my weekend.